Hello. Hello. Let me discuss about the timer counter 8051 microcontroller. 8051 microcontroller has two 16-bit up counters T1 and T0. It's timer 0, timer 1. It is also called counter 0, counter 1. So if it counts internal clock as an input, it is known as timer. Suppose it counts as an external clock, we are going to call it a counter. So counter, the input will be from external, but timer is the internal clock, the input. So each timer or counter is given to two. That is, it is having two 8-bit registers. TS0, yeah, TL0. Actually, it is a 16-bit register. So it consists of two registers. Each register consists of 8-bit. TL0 it holds the 8-bit. TS0 it holds the 8-bit. Similarly, TL1 hold 8-bit. TH1 hold 8-bit. So timer or counter is controlled by TCON and TMOD registers. So we should know how we are going to control, configure these timers, counters by using TMOD and TCON register. So let us we discuss about the TMOD register. It's called timer mode register. It is of 8-bit register. So first here 4 bits right hand side is for timer 0 counter 0 and left hand side 4 bits is for timer 1 counter 1. So here both are same here 4 bits. This 4 bits is for timer 0 counter 0 and the left side 4 bits for timer 1 counter 1. So here M0 and M1 for mode selection, timer 0 or counter 0. So 0 0 mode 0, it is a 13-bit maximum you can have the count, and mode 1 16-bit, mode 2 8-bit auto reload, mode 3 split mode. Then this bit is for counter or timer. The same device can be used as a timer or counter. If you are going to use as a counter, this bit should be 1. If you are going to use the timer, this should be 0. So now gate. So here you can control the start and stop of the timer or counter either just by executing an instruction, that is called a software control, or by external physical signal we can make it start or stop. So if it is just by executing an instruction, software control, in that case gate is 0. Similarly, the left hand side 4 bits is for timer 1 and counter 1. Then we have TCON register, timer control register. So these 4 bits is for interrupt purpose, and these 4 bits for the timer start and its flag status. Once overflow occur, the corresponding flag become 1. See here, this left hand side for timer TR0 to start the timer 0 or counter 0, this TR0 bit should be 1. Then once overflow occur, this flag become 1. Timer overflow flag 0, timer 0 overflow flag. 0 stands for timer 0 or counter 0 and 1 stands for timer 1 or counter 1. So similarly TR1 and TF1 for timer 1 or counter 1. Then similarly, let us see about interrupt also. So we are going to use. So IT 0, IE 0. IT 0 is to, if it is 1 means it is a falling edge signal will be, interrupt will be recognized. Whenever physically interrupt signal is occur at the external input, then if it is a falling edge, negative edge trigger occur on this pin, then only it will be considered. So two methods, either low level signal or falling edge. If it is 1, this bit means it will be considered as a edge trigger. Whenever interrupt occur, it should send as a falling edge signal, then only it is going to consider as an interrupt signal. If it is 0, this bit, that will be considered. If 0 means you need to send as a interrupt a low signal. Okay, low pulse you have to send. So this is for interrupt 0. So once if you set, the corresponding flag will be enabled. Whenever an edge trigger occur, this become high. This I is 0. So similarly, IT1 and IE1 for interrupt 1. There are two other, interrupt 0 and interrupt 1. INT 0 and INT 1. Then remaining these four bits for timer and counter, as I explained you. Then the registers, we need to store the count value in the registers. TL0 and TS0 for timer 0. This each is of 8-bit. TL0 is of 8-bit register. TS0 is of 8-bit register. Total it is a 16-bit register. Timer 0. Similarly, for timer 1 also, it is a 16-bit register. TH1 and TL1. TL1 is of 8-bit register. TH1 is of 8-bit register. Combined it is a 16-bit register. Now, let us see how we are going to use as a counter. The timer can be used as a counter for counting the external objects. Count the number of events occur at the external pins. So, see that external input from T0 will be as a counter 0, from T1 for counter 1 input. See here, T0 means if you are using as a counter 0, is external signal you need to connect for the T0 pin, means nothing but port 3.4 pin you need to connect external signal. So now, as we discussed about the modes, mode 0, mode 1, mode 2, mode 3. See, for mode 0, here the all we can able to understand like counter slash timer. If it is a timer, 0 means it is going to take the input from the clock oscillator, and is divided by 12. That is the input for this timer. So if it is 1 means as a counter, for counter external input. The counter external input here, this selection. Then here gate, as I told you, gate selection. Gate, the start and stop of this timer will be controlled by just executing an instruction, or external physical signal also you can use. If gate 1 means from external signal you can control the start and stop. Yeah, this gate. Okay. Now TR0, as I told you, this is TR0, timer run 0. If it is 1 means this will be connected, means whatever the clock input will be connected to the timer for counting to start counting function. So once overflow occur, then TF flag become high. See here it is only count from 0 to 8191. Is only because it is 13 bit. For mode 0 it is a 13-bit count only. Similarly, all the operations same, only changes is this, the capacity of the counter. Mode 1 16-bit. 0 to 65,535. Mode 2 is 8-bit auto reload mode. 8-bit it will count. Then mode 3, two different, each is of 8-bit. Okay. So the different modes. Now let us look at the general the diagram, how we are going to apply in brief, in simple way you can able to understand here. See here, the crystal oscillator, its clock is divided by 12 and given to the timer input. If you are going to use as a timer, if you are going to use as a counter, T not pin for timer 0, I mean counter 0 as an input. Either you can connect from this or from this. If you are going to use as a timer, the input will be this one, clock, the known frequency. Then if it uses a counter, we don't know at what time the object may occur. So whenever it will occur, just to count. That is a counting function. Okay. Then here, either you can control the start and stop just by using TR0 or physical signal, as I told you, from external physical signal. So gate 0 means one of the input of OR gate become 1 and this is 1. So its output depends upon this only, that instruction, by using an instruction. If it is 1, means this OR gate output is depend upon external physical signal. Then in turn it is going to depend upon this physical signal plus this instruction. So this gate 0 means it is totally depend upon only this TR0. If it is 1 means it is going to depend upon external physical signal also, the start and stop of the timer. So here, if this is 1, then it is this input is connected to the timer. Once overflow occurs, whenever it reaches the FFFF maximum value in 16-bit, then it is go to 0. Once it reaches maximum value of FFF, that goes to 0, then overflow flag become 1. So this is how they are shown with some numbers. Like for example, starting value, suppose load FFFC, then start the timer. So beginning timer overflow flag is 0. Then for one flag pulse it reached FFD, the next flag pulse FFE, then next flag pulse FFF, then it will go to 0, another flag pulse, then overflow event, then stop the timer. Okay, TF flag become 1. So always we are going to monitor the TF flag here. Whenever 1, stop the counting. Similarly, here same diagram. Once again, I shown you how to work this number. So it will be stored here. This number, suppose FFFC will be stored here. The flag is applied. Timer run will be started. Initially, timer overflow flag will be 0. Once overflow occur, when it reaches FF then will go to 0. Then this TF flag become 1. Like this is going to work. So during counter operation, it's going to count simply from 0, 1, 2, 3 like that. This is a counting function. Then once it reaches FF, it will come to 0. As you know that is a function. Okay. So remaining we'll see in the next class.